Hi everybody, today I can find the remainder when polynomials are divided using the remainder theorem by just substituting the opposite of what I'm dividing by into the function. So we know to find the remainder, we could find the quotient and the remainder using synthetic division or long division, but there's an easier way if I'm just asked for the remainder. So if I'm asked for the quotient, I'm going to use synthetic division or long division. If I'm just asked for the remainder, we're going to use remainder theorem. So let's start by using what we already know. Let's start by finding the quotient using remainder, using synthetic division. So I'm going to list my coefficients, make my big L, put the opposite of what I'm dividing by outside, and then I multiply, add. Bring down the first one, multiply, add. Multiply, add, multiply, add. So my remainder is 0. I know that my quotient is x squared minus 4x plus 1, but I'm not asking for that. All I'm asking for is the remainder, which in this case is 0. Now, there's an easier and faster way to find the remainder, and that is using what's called remainder theorem. So here's how remainder theorem works. I am going to substitute the opposite of what I'm dividing by. So this number that goes outside for the synthetic division, I'm going to substitute that value into the function. So I'm going to erase this to create some more space. And I'm going to do 5 cubed minus 9 times 5 squared plus 21 times 5 minus 5. I'm going to go to my calculator, which is going to pop up. There it is. And I'm going to type in parentheses 5 cubed minus 9 times 5 squared plus 21 times 5 minus 5. And you see you get the same value that we got with synthetic division, which is 0. Remainder theorem will not give you the quotient. It will only give you the remainder. Now, I want to show you something to make this even easier. It's a function in the calculator called storing. So here's what I'm going to do. If I want to plug a value, if I want to substitute a value into something, I'm going to store it. So in this case, I'm substituting 5 in. So I'm going to hit 5, store. Store is above the on button in the bottom left-hand corner. Let me see if I can actually quickly show you that. Transparent background, perfect. So the store button is right here. So let me get back out of that. Pull the calculator back up. So I'm going to do 5 store as x. And then I'm just going to type in what I'm substituting into. X cubed minus 9x squared plus 21x minus 5. And I get 0. So you don't have to do it with storing, but you're going to see it's going to be a lot easier and faster and less likely to make a mistake once you master the storing. Either way, the remainder is 0. So to find, when you're being asked for the remainder, we use remainder theorem. To do remainder theorem, we're substituting the opposite of what we're dividing by into the function. Whatever I get, that's my remainder. Let's try number 2. I want to find the remainder when these are divided, so I'm going to substitute the opposite of what I'm dividing by into the function. So the opposite of x plus 4 is negative 4. So I'm going to replace the x's with negative 4's. And now I'm going to type that into the calculator. I could do it with storing, or I can do it without storing. I'm going to do it with storing because why make things harder than they have to be? Negative 4, store as x. And now I can type in x to the 4th minus 8x squared plus 3x. And we're going to use storing a lot in this course. 116 is my answer. So the remainder is 116. If I use synthetic division, I would have gotten 116. If I used long division, I would have gotten 116. Now again, if you don't have this calculator right now, you could just, in parentheses, negative 4 to the fourth minus 8 times negative 4 squared plus 3 times negative 4. And you'll see you get the same thing. Let's try one more. I'm going to give you an opportunity to try number 3 on your own. So why don't you just pause it for a moment, because I'm going to start in about 10 seconds. Okay, so if I want to find the remainder when I divide by x minus 3, I'm going to substitute the opposite of what I'm dividing by into the function. So if I'm dividing by x minus 3, I'm going to substitute 3 into the function. So I'm going to get 3 cubed minus 2 times 3 squared plus 6 times 3 minus 2. I'm going to go to my calculator. I'm going to do it with storing. I'm going to store 3 since that's what I'm substituting in. And then I'm just going to type in x to the power of 3 minus 2x squared plus 6x minus 2. 25 is my answer. I'm done. Now, that's using remainder theorem algebraically. We're now going to use remainder theorem graphically. First off, I believe I changed this little 2 to a 1 to make things a little bit less complicated. It wants to know the remainder when I'm dividing by part A is x minus 1. So to find the remainder when I divide by x minus 1, I'm substituting the opposite of that into the function. So how do I do p of 1 graphically? Well, basically what this is saying is that x is 1. So when x is 1, what's the y value? Well, when x is 1, as you can see from this point right here, y is negative 3. So your remainder would be negative 3. And that's just evaluating functions graphically. If you want to evaluate a function graphically, you're putting in the x value and you're seeing what that corresponding y value is. B, if I want to know the remainder when I divide by x plus 2, then I'm going to substitute negative 2 in for x. So when x is negative 2, the y value is negative 10. If I want to know the remainder when I divide by x minus 3, then I'm substituting 3 into the function. When x is 3, y is 0. So the remainder would be 0. And for D, I'm putting the opposite of what I'm dividing by. Well, for x special, x is technically x plus 0, so the opposite of 0 is 0. And we talked about that in the last lesson. If x is a factor, then 0 is the corresponding 0. So when I plug in 0 to the function, when x is 0, y is also 0. So to find the remainder, you're substituting the opposite of what you're dividing by into the function. If you're doing it graphically, you're finding the corresponding y value for each of those x values. If you're doing it algebraically, you're just substituting that value into the function. And again, it will be easier if you use your storing function in your calculator. Your classwork/homework is to finish remainder theorem, and then the next lesson is going to build on remainder theorem. Have a great day, and FYI, this is the first ever video I recorded outside. I'm sitting outside in the courtyard right now. It's really nice. Hopefully the sound comes through nice.